Hey guys! So today you and I are going to talk about task-oriented programming. So let's get into it. So the question in question was, Frederick, what is task-oriented programming and should I learn it? And the short answer is, you can check it out, but odds are that you will never ever do it. Let me explain. So task-oriented programming is, honestly, it's more of it's a mental exercise designed for systems that are going to be so inaccessible or so dependent on being future-proof that you're willing to basically create your own pseudo-language and then a runtime a custom runtime that can parse that pseudo-language. This sounds very fancy, but it's actually very similar to how most scripting languages work. So you can think of, take something like Python or PHP or something like that, just as an example, right? Let's say that you wanted to create a way of expressing logic within a program that didn't require you to tie yourself into a specific programming language. Now, if we pretended like PHP wasn't like an established programming language, let's just say, because it's just a script. Remember, a PHP file or a Python file, it's just text, guys. It means nothing. There is no compilation or anything like that. There is a runtime or an interpreter, which is a program that will parse the symbols in that file and convert that into executable, well, basically ones and zeros under the hood at the end of the day, but it's just going to pipe through the file into itself and then execute the commands that are found in that file. Now, you could today, if you wanted to, you could create your own runtime. You could create a runtime like you completely your own language, a very simple language, something where, oh, if you write, I don't know, foobar equals 1, well, then the runtime should should understand that, oh, there should be a variable equal to 1. Like, you can do it yourself. And that's what task-oriented programming is kind of about, where the idea behind this is basically that technology changes over time. It might be that, oh, if you build the Mars rover, let's say for the sake of argument that we decided to make some type of spaceship type of thing or something like that, that's going to go to outer space. Well, if, let's say for the sake of argument, that the architect there decided that, hey, we're going to do that in Ruby, well, then it might be the case that they realize later on that, oh shit, this was a really bad pick for this sort of project. But you can't really go out into outer space now and go and get that fucking rover back. That's going to be very hard. So now you're kind of stuck with it, and maybe millions and millions and millions of dollars have gone to waste because you picked the wrong language. But task-oriented programming is different, because in this scenario, what you do is instead that you create a pseudo-language. It's similar to, you can think of it as, if you've ever worked with something like Swagger or similar things, where you might declare your logic in a JSON file. Well, the task-oriented programming doesn't mean JSON, it's just text. You just declare that you have a fork like a fork or an if-else statement. You basically just write it down in a technology-neutral format. And then you create a runtime. In other words, you create let's say that you wanted to write a C program. Well, then you're not going to write a C program. You're going to write a specification for what your C program should do. And then you should have a runtime or a transpiler or something like that that knows how to convert your text representation of the program into actual C code, if that makes sense. It becomes an interface. It becomes another layer between the running zeros and ones, like the actual program that's going to run, and the code. For lack of a better analogy, it's very similar to how we do things with Babel in JavaScript, for example, where you might have a middle layer between JavaScript and the thing that's going to run in the browser that actually just converts or transpiles your JavaScript code into JavaScript code that has more features or things of this nature. It's just that you're doing this with some type of text format. It doesn't have to be text, but in general, this is the idea. What this allows you to do is that if you now have something like, say, a Mars rover, and let's say that you just realize that, shit, we need to have, I don't know, a different programming language because Ruby was a really bad choice for this, or whatever language you wrote this in, well, then you can remotely deploy a new runtime to the hard drive of that rover, and then with a new interpreter, and your specification file, your program will still work. That's the beautiful part about it. You don't have, your program is not tied into the code that is running in that Mars rover or that remote system. It's in the text files. It's represented through that in these text files. And there's not that many, I don't think I've ever talked to anybody even who has done this, who has been working in this fashion, because it's a very complicated thing to do. And for most intents and purposes, you're never going to have to use this, but it's an interesting concept. It's an interesting idea. The closest thing that you're going to face, I think, if you're doing something like web development or similar things here in the real world, is that you might have people who suggest that you should generate API clients. So in the case, as I was saying, with Swagger, where you might document your API through a JSON format or a YAML format or something like that, then you can actually, there are tools to do this as well, where you can parse that file and translate that into code. You can generate code based on those specifications, and this is actually, there's actually a few companies that do this. And Google, for example, they have, I think it's called JRPC, it's a similar sort of thing, where you don't write your API and your API clients, the thing that is going to connect to your different endpoints, yourself. You create a JSON document or something like that that can be used in order to generate that code for you. And that's really, really powerful. And that is very much in line with the sort of mentality that task-oriented programming is trying to leverage. Because when you do that, you decouple your logic from the actual code, which means that you can generate your clients for anything. Like if you have your API specification in Swagger, or something like that, then you can generate API clients or SDKs for any language, for PHP, for Go, for Ruby, for Python, for JavaScript. It doesn't really matter, because as long as you have a program that knows how to convert that text into working software, you're good. So what I want you to take away from this is that you're very unlikely to ever need to go and dive deep into task-oriented programming, but take a look at it, because it's an interesting idea. It's a very interesting idea, and it touches on something that I think that is very useful, and that is to understand the value of code generation. Now, code generation is very, very tricky sometimes to do well, and it's not something that you necessarily need to know about or ever do, but I've found myself in a few projects that I worked on where it's actually really, really useful to be able to generate code for the developer based on something else, not some text file or some requirement or a command or something like that. You may know about the Geoman or other these types of templating engines where you can template up an entire project. These sorts of ideas are very much in line with the basic idea of how task-oriented programming would work. But as I said, you're not going to have to study it all that rigorously, because the odds are that you will never work on a project that leverages this type of work. Have a great day.